Example number 2, determine the total number of outcomes from 3 or more events. So, in this situation, we're going to flip a coin. That's one experiment. Spin a spinner is a second experiment. And roll a 4-sided die. That's the third experiment. And here it is here. Flip a coin, spin a spinner, 4-sided die. How many possible outcomes are there? So in this case, you can do a tree diagram. And this way, this time we're going to do a vertical tree instead of a horizontal one. So the coin, you had 2 possible outcomes. Spinner had 3, so each coin outcome gets 3. So A, B, C, A, B, C. And then each of those gets the outcomes from the die, which was 1, 2, 3, 4. So there are a lot of possible outcomes. So you can get a heads, an A, and a 1. I'm writing these vertically on here just because there isn't enough space to do them in a row with commas. So a fair bit of writing to fill these in, especially when you've got more than 2 experiments going on. So that's all the different possibilities with heads. This other half is all the possibilities with tails, and it looks almost the same except we've got a T across the top instead of an A or an H. So there's all your possible outcomes, and in this case there are 24 possibilities. If you count, there's 24 items listed here. So that's the number of possible outcomes. Now, you can use multiplication again, rather than going through the tree process. Now, please take note, with 3 or more experiments involved, a table is not possible any longer because the table has an x-axis or a y-axis. It has rows and columns. So that's 2 dimensions to it. Once you add a third experiment, you can't really draw a table with a third dimension. So you need to resort to something like a tree diagram for 3 or more experiments. So, number of possible outcomes with a coin, well, it's heads or tails, so that's 2 possibilities. The spinner, in this case, had 3 outcomes, A, B, or C. And the 4-sided die has 4, 1, 2, 3, and 4. So you can multiply those numbers together, 2 times 3 times 4, 2 times 3 times 4, and that will give you 24, which is exactly what we came up with in our tree diagram. So there are 24 possible outcomes. And here's part B. Why would it be difficult to show the sample space for this experiment in a table? Well, as I said, you can use a table for 2 events. You can show one event in a column and the other in the row. But once you get to 3, you don't have a third element to your table. So unless you could draw a table in 3D that comes out of your paper, you wouldn't be able to do one with 3 events in a table. All right, last up for 11.2 is another show you know. Please go ahead and do that.